Now we are going to look for a relationship between polar coordinates and the Cartesian coordinate system. So first of all, what you have to understand is this polar coordinate and the Cartesian system are two independent systems, right? So for the the Cartesian coordinate system, you have something like this, an x-axis and a y-axis along with a origin, right? And for the polar coordinates, you only have a straight line, and then you name this center point as the pole, right? So these two are two totally different environments, right? Two totally different universes, right? So now also this straight line need not to be horizontal all the time, right? So the only requirement you have here is to have a straight line extending from the pole, right? But if we take a copy of this straight line, right, and then coincide it with the x-axis, the positive x-axis of the Cartesian plane, then we will be able to obtain a relationship between Cartesian coordinates and the polar coordinates. So now you have to understand this clearly, right? Here at the beginning we had the Cartesian system and the polar system, right? And these two are two different universes, right? They are totally independent environments, but there is a way to relate these two conditions, right? These two universes. What we do is we just take this straight line and keep it in a way that it coincides with the positive direction of the x-axis. Then we will be able to come up with some relationships that is common for both Cartesian plane and the polar coordinate system. So now in both these systems, our intention is to indicate the position of a given point, right? Say for example, if we have this point in the Cartesian system, what we do is we get the distance along x-axis, which is this one, and the distance along y-axis, which is this one, and mention it as a coordinate pair. And for the polar coordinate system, what we do is we measure this angle and this radius r and measure it as a, indicate it as a coordinate pair. So this is the polar coordinate system and this is the Cartesian system, right? Now if you look at this diagram, you can come up with a certain simple relationship. So that relationship is, from the Pythagorean identity, we have r squared is equal to x squared plus y squared, and tan theta is equal to y divided by x, right? So this is the relationship between polar coordinates and the Cartesian coordinates, right? Now also there's one more thing. Even if this point is not in the first quadrant, let's say if we have a point somewhere here, right? So it will be something like let's take this as -5 and this as 3. Then r can be obtained through this equation. So r will be -5 squared plus 3 squared. Sorry, this should be -3, right? Because it is in the negative side of the y-axis, right? So this will be -3 squared. And tan theta, that also can be obtained directly from this equation. So what you have to do is you have to mention these values along with the plus and minus signs, right? So this will be negative 3 over negative 5, which is 3 over 5. See, remember now, in the third quadrant, tan theta is positive, which is kind of expressed in this equation as well, right? But the thing is now, if you get the theta value, that is tan inverse of this number, sometimes, like if you just evaluate the angle through this equation directly, then you can even get into this situation as well. Now if you have this as 3 and this as 5, right? So for this case also, theta will be equal to tan inverse 3 over 5, right? But here also tan inverse 3 over 5, but actually we need this angle, right? So now anyway, if you can remember, now when you evaluate these trigonometric terms, there are no unique solutions, right? For this sort of a thing, there are so many theta values that will satisfy this sort of an equation. So we have to choose the required theta appropriately. That means you have to know the position of this object in these 4 quadrants, right? So then only you can correctly obtain the theta value. Otherwise, if you just write down the suitable theta value, then it might not correctly illustrate the exact position of the given point.